Okay, so in this PowerPoint, we're going to discuss the laws of gravity, forces, and Newton. So Newton had a few laws. So Newton's first law of motion states that an object at rest will stay at rest until a force acts upon it, or an object in motion will stay in motion until a force acts on it. So here you can see the motorcycle driver as he hit the barrier of tires and then continued to go forward. Um, as far as an object at rest, well, let's use my children for an example. My children will stay asleep until I kick them out of bed. That force of me kicking my children out of bed will enable them to get up and start getting ready for the day. This is called the law of inertia. Newton's second law says how much an object accelerates depends on its mass and the force acting on it. So it doesn't take much to move a balloon, right? So it would move much faster if I applied a large force to it. Now, if I had a giant boulder and I applied the same force, the acceleration would not be as fast, right? So I can apply that same force, but because the boulder is much larger than the balloon, then it's not going to go as far. So Newton's third law says that every action has an equal and opposite reaction. So here, as you see the balloon, if you open the balloon, right, the force of all of that air inside the balloon is going to push it down. And what happens then as the opposite reaction, the balloon then goes up. And then you have Newton's universal gravitational law. And it basically says that that force of gravity between two objects depends on the mass of each object and that distance. So one example I've shown you in class is the magnets. So if I have my magnets with a very close distance, then the force of attraction will bring those magnets crashing into each other. But as I increase that distance, then the magnets are not going to have that big of an impact on each other. So this is same true as far as the gravity of, say, like the moon and the Earth. So again, just stating that the force of gravity is equal to the gravitational constant, which is what we use a capital G, multiplied by the mass of the two objects. So that would be m, big M, little m. Sometimes you'll also see it as m subscript 1 or m subscript 2, divided by the distance between them squared. So the mass is directly proportional to the force of gravity. Remember, directly proportional means that if the mass goes up, then the force of gravity goes up, right? So they are both going to increase. Indirectly proportional means the opposite. So the distance is indirectly proportional to the force of gravity. So when I increase that distance, then the force of gravity decreases. So only the effect of forces can be seen. Forces are measured in a unit called newtons with a capital N, and they usually act in pairs. So like the first law of inertia, so once you get an object motion, you have to generally apply that force, which then would also be Newton's second law. And they always act in a direction. Two things make up a force: how strong a push or pull is, and direction, in which way the push and pull is. And we draw these with arrows. The arrows, the length of the arrow will tell you how strong that force is, and then the direction shows you, the direction the arrow points shows you the direction in which the force is pulling or pushing. There are balanced forces and unbalanced forces. So a balanced force produces no change in movement. So that means that the force moving against each other is the exact same. If you think of like a tug of war, right? Equal people, if you're playing a tug of war against yourself, you're not going to move. But then if you look at the unbalanced forces here with the little chickens, then you see that there's going to be a change in direction. So an unbalanced force has a change in speed and or the direction of the objects. Forces are nearly always going to be some kind of push or pull. So the movement would go in the direction of the force. Forces can make objects do 5 different types of things. Speed up, like when you're kicking a ball, or slowing down, like the drag of air resistance. A change in direction, like when you hit a ball with a bat. Turning, like when you're using a spanner wrench. And changing in shape, like twisting, stretching, compressing, and bending. Again, balanced forces show equal forces acting on one object in opposite directions. There's no change in movement. Whereas a unbalanced force, there's going to be an unequal forces acting upon each other. So the bigger force will always win out. So as the truck is moving, the air resistance against it is less, and so the truck is going to move forward. Just another diagram showing you what balanced forces are. No acceleration, no movement. Remember, acceleration is that change in velocity. If there's no velocity, there's no acceleration. Here you see the different color arrows and you can see which direction the movement will go. 50 newtons is larger than 30, so the gentleman on the left will win. If you look at the bird, air friction is not going to be as big of a force as the force of gravity and the weight, so the bird's going to go down. Looking at the next one, if you have 4 newtons to the right and 3 newtons to the left, then it's going to move right. And then finally, looking at the rocket ship, we have 300 newtons that's going to push it up and only 100 that's pushing down. So the rocket will go up. And then here's just kind of a concept map situation where you can see what they have in common and what they don't. So the one little bubble in the middle shows the one relationship that balanced forces and unbalanced forces have in common, whereas the red shows just balanced forces and the blue shows just the unbalanced forces.